So, welcome to the main lecture for Chapter 4. Before we get started, I just want to give the preface of this may feel like a more biologically heavy chapter. However, it's really important for us to think about a person as a whole and how physical development in particular may be connected to other aspects of growth, such as social, cognitive, or emotional development. Hopefully, this lecture will make it easier for you to digest that information and be able to give some context to what the book is talking about. So let's go ahead and get started. So on this slide, the learning objectives for this chapter are listed. It might be useful to revisit this slide once you've completed the lecture, watched the videos, and taken notes to check if you're able to complete the objectives on your own before taking the quiz. So in this slide, we'll talk about the major structures of the brain and how they develop over time. At birth, the medulla and the midbrain are largely developed. These two structures are in charge of regulating vital functions such as the heartbeat, respiration, attention, sleeping, waking, elimination, and the movement of the head and neck. So from a developmental perspective, it's not hard to see why they had to be the most fully developed parts of the brain when the baby's born. Those functions are vital for survival. However, the least developed part of the brain at birth is something called the cerebral cortex. That's the outer covering of the gray matter over the hemisphere. It's the largest, most complex brain structure involved in perception, body movement, thinking, and language. So the cerebral cortex is the last brain structure to stop growing, which makes sense considering its function, and is sensitive to environmental influences for much longer than other parts of the brain. So even though in the first 2 years after birth, it's primarily the cortex that's developing, other neurons are still developing throughout the nervous system. So next we'll talk about the brain and the nervous system, particularly the growth spurt that's happening on a developmental timeline. On Blackboard, you'll find a study guide called Brain Development to help capture some of these highlights from birth to adolescence. A couple of key things to remember. First one is most of these growths are happening in spurts, so they're not continuous. And two, they're localized, which means these growth changes are happening in just one or just a few parts of the brain instead of the whole brain at once. Neuropsychologists have related some of these physical brain growth spurts with changes that are also happening in the cognitive development. So for example, at 20 months, that particular growth spurt happened to correspond with toddlers' goal-directed behavior, while spurts at age 4 corresponds to an explosion of language and their fluency. Two other growth spurts that's occurring in middle childhood. One is 6 to 8-year-olds have an improved hand-eye coordination and finer motor skills. That's right around the time they start school. Whereas 10 to 12-year-olds have growth spurt that's corresponding to improved logic and planning as well as memory, which is pretty typical of what we would expect of someone entering kind of their teenage years. Next, we'll talk about synaptic development. So synaptogenesis is the process of creating connections, aka synapses, between the neurons. So neurons sense messages to one another by releasing chemicals called neurotransmitters, which crosses the synapse. So think back to the first week when we talked about that idea of maintenance in Aslan's environmental model. That's the idea of if you don't use it, you lose it. That's their explanation to change. So this applies to the principle of pruning. This is where neurons, where the ones that are rarely stimulated, lose their synapses or connection. This is to make sure the pathways are used most efficiently and effectively. Next, we'll talk about brain plasticity. So brain plasticity refers to the ability of the brain to reorganize itself due to experience. You might have heard of people who've suffered brain injury after accidents, where parts of their brain was damaged. However, after therapy or after other medical treatments, they're able to regain some of the function. This is due to brain plasticity and its ability to make new connections. So apply this to kind of infancy and toddlerhood. Because many of these synapses or connections aren't fully established yet, the brain is much more plastic or flexible during the first few years than any later times of life. However, because of this increased sensitivity and, I guess, flexibility, the brain is also more vulnerable during the first few years of life. So, for example, if a baby's malnourished, the impact on the baby is much greater, much more harmful than a teenager's brain or your brain or my brain. So, next we'll talk about patterns of change in size and shape, namely height and weight gain. So, over time until adolescence, human growth can be broken down to three major phases. First phase, which lasts for the first 2 years of life, the baby gains height and weight at a very rapid phase, and then settles down to a much slower but steadier pattern of growth until adolescence. How fast, you might ask? So, by the time a child reaches his or her first birthday, the baby, turning into a toddler, would have tripled his or her body weight and double his or her height. Another interesting fact, by the time a child reaches his or her second birthday, he or she would have tripled the brain weight of his or her birth brain size. So whatever the brain size was at birth, by the time of the second birthday, it would have been 3 times as much by the time he or she celebrates the second birthday. So that's pretty amazing. So during the second phase of growth, the children's growth become much more predictable from one point of measurement to another. That's when they're leveling out. And we use something called percentile rank to describe how the child compares to others of the same age. So percentile rank represents the percentage of individuals whose measurement is equal or less than the child we're talking about. So once the child's percentile rank for height and weight becomes stable, the child is said to have established his or her individual growth curve, or the rate of growth. The third phase is what we call the dramatic adolescence growth spurt, the growing pains. This is when a child may gain 3 to 6 inches a year for several years, after which the growth of rate again slows down to the final adult size is reached. So next we'll talk about muscles and body fat and how they change over time. Muscles, for instance, change in their quality from infancy to adolescence. They become much longer, much thicker at a fairly steady rate throughout childhood. And during adolescence, muscles go through a significant growth spurt. Adolescents become much stronger in just a few years. And this increase in strength is evident in both girls and boys. However, as you can see in this chart, the increase is much greater in boys. Next, we'll talk about body fat. It's mostly stored immediately under the skin. This subcutaneous fat first develops prenatally and then peaks during the first few years of life. You can kind of see that with the chubby babies and, the pinchable cheeks. This layer of subcutaneous fat then declines until about age 6 or 7. After then, it rises until adolescence. Girls tend to have slightly more fat tissues than boys at birth, and this difference between boys and girls becomes gradually much more evident during childhood and adolescence. So next we'll talk about how our use of our body changes over time, particularly how our stamina changes. So stamina is the capacity to sustain motor activity. It increases as the heart and lung grows larger and becomes much more efficient. This occurs especially during puberty. Before puberty, boys and girls are fairly similar in their physical strength, speed, and stamina. After puberty, boys are ahead in all 3 of those areas. However, in terms of motor development, while boys are much better at gross motor skills, girls are actually better at finer motor skills, which we'll talk about in a little bit. So here's a picture of stages in children's drawing and how they change over time. Looking at this picture, what can you conclude about children's motor development based on their drawing at different age? Other than the motor skills, what else can you observe about their development? For instance, what can you say about their perceptual or cognitive abilities? You don't need to use technical language, but just look at the differences and describe what you see. For now, we'll focus more on motor activities and motor development, and we'll connect all this in later chapters as well. So motor development includes both the movement skills called gross motor skills, which boys are better at, and the manipulative skills called fine motor skills, which girls tend to be better at. On page 91 of your textbook, you can also see a side-by-side comparison of these two types of motor skills broken down by age and how they develop over time. In general, gross motor skills develop earlier than fine motor skills. They're fairly developed by the time we reach age 7. Whereas fine motor skills, they develop rather rapidly during elementary schools. Why do you think that is? Do you think it's more biologically based? Do you think it has something to do with schooling? And why do you think girls are generally more advanced in fine motor skills than boys? And do you think this is cultural specific or universal? Here are some of the questions I want you to think about as we'll touch upon it in our class activity. So we've reached the end of my lecture. Hope you've enjoyed it and was able to kind of grasp some of the concepts a little bit better. Still refer to your textbook and peruse through the sections that we didn't touch on, but this should help you to get a better sense of the foundations of physical development. Finally, if you haven't seen the Khan Academy video that I've emailed out earlier, here's your chance to do that. Just click on the specific videos. It should take you to the 4 videos accordingly. It should take you less than 20 minutes to go through all those, but if you pause and take notes, it could take a little bit longer. They're pretty fun and interesting and gives a pretty understandable explanation to what's happening to motor development and physical development of various sort during early stages of infancy all the way to adolescence. So do make sure you check them out as you'll be tested on some of them on the quiz. Again, if you have any questions, let me know, but I'll see you in class and take care.